Now, let's talk about where we're at and what we're going to do. We just had some really good successes in this cleanup, and now I want to attack the complexity of what happens when you call a procedure. So here, when you call a procedure, there's a bunch of things that can happen. It could be overloaded. You have to find, which overload it is and stuff, which itself has complexities. And I'm going to write that down to look into that later. But ignoring that, I'll ignore that for a minute. So if the overload that we come up with is polymorphic, then we have to do this procedure that goes and binds the variables, and that calls a lot of the routines that we've been working on and simplifying, right? So that's fine. Just for a regular polymorphic procedure, this happens. But then, then some other stuff happens. And then down here, if it has value bakes, then we call resolve potential value bakes in a separate phase. This is the two-phase thing that I've been referring to before. And resolve potential value bakes does a bunch of stuff and then calls do polymorph, right? So if you're calling a procedure that has polymorphic arguments and value bakes, then it gets polymorphed twice. So like something like if I have f, a is a t, and b is some int, right? Anytime you call this, it actually gets polymorphed twice. And I don't think that's good, and especially, it's not good in terms of clarity of the code, and especially if you start adding a modified proc onto here, like that's probably should get called twice, which is also, not good. Like you'd rather have all this stuff resolved simultaneously, I think I'm saying, right? Now again, this isn't twice because there's two $signs. It's twice because there's a $signs on the right and $signs on the left. So one phase is the $signs on the right, and the other phase is the $signs on the left. And so what I would like to do is combine those. So what I want to do is I want to bubble this piece of code up. I'm pretty sure it doesn't matter when this happens, as long as it happens after the other thing. So I think, it has to happen after type check arguments, doesn't it? Because we have to know what they are. Ah, that sucks. No, it has to happen down here. Except this type check arguments is kind of redundant because when we do the polymorph, we have to So there's all sorts of redundancy that happens in here. Like to figure out which polymorph to use, we're doing type checking. So we have to do all the type checking on everything. And then we throw away the types we decided for well, we don't exactly throw it away. The information is there because we get this procedure back, right? But then we essentially do it again now that we have the real final procedure, except it's not final because we do the bakes. So what I would like to do, what do I have to do? I would like to... Okay, so part of the whole reason that I was doing all the earlier work is to make it so that these $signs on the left and the $signs on the right work the same, which they do now and they didn't used to. Now that they work the same, I think my strategy is going to be, instead of doing this way down here, I'm going to pass the value bake information. There's no value bake information to pass. I'm going to resolve $signs on the right and left at the same time. I'm just going to look at what this does, and I'm going to try to fold it into what this does. I don't know. This could be messy. We're going to see what happens. Okay. Anyway. First, I'm going to turn the light on. I'm going to comment this out. And this should break very badly. But I want to see what it looks like when it breaks badly so that I know what to fix. Okay, so what does it look like when it breaks badly? Oh yeah, that's bad. It's saying polymorph detection. That's a really old printf. I don't even know. Yeah, it's. Let's see what happens if we try to do Sokobon. So this X fixed array assert is going on. It's probably failing some polymorph in the same way in like a standard library. So, okay. So let us see what resolve potential value bakes does. Nobody else calls this, right? Potential value bakes. Yeah, that's the only person who calls it. So we're going to just assert that this is true. I'm going to re-enable this for a bit. Because again, I want a working program while I do this kind of modification. Boop, 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 boop. So basically, we're looping over all the arguments and finding if any of the individual declarations have out of value bake, and we do all this stuff. This stuff is stuff that could go in the loop for polymorph. Okay. Anyway, so very small simplification there of taking out one layer of if. Okay, well this has to go first. Okay, so that is going. Okay. Now, resolve potential polymorphs calls sort call arguments and maybe polymorph, and then does some things. So all the work really happens in sort call arguments and maybe polymorph. So we sort the arguments. Get lambda from procedure proc expression. Does sort arguments change proc expression? Okay, no. So what happens is we suck, okay, if it's not polymorphic, then we just sort the arguments and return, right? Which is no good if there are value bakes, so we're going to have to think about that. If we did a polymorph and we had some default arguments, we need to infer the types of those arguments. So we're type checking even more than we thought. Yeah, like, okay. So this type checking just does the same as like the type checking that we were doing. I'm in the wrong place, I think. Yeah. So here when we say type check arguments, we're doing the same things. Boy, type check arguments sure takes a lot of arguments. Maybe that could be simplified. I have all these, again, sometimes the tactic I choose at the beginning is to do small simplifications where I can get them, and then it becomes easier or more obvious how to combine the bigger things. Well, okay, wait. Here's what I don't get. Who else calls this? So it's resolve potential polymorphs. It's type check one overload. That's it. Okay, so and both of these call type check arguments afterward, which I think means this entire thing is not necessary anymore because we call check the types match on everything at the calling site. So this was like somebody got confused, or somebody is me, about what was whose job. Yeah. So, okay, that's good. That stuff's unnecessary. I mean, let's run it to make sure, but okay. So, let's get rid of that. That is good. I mean, this is still a bigger procedure than I would like it to be, but that's good. I'm going to look at simplifying sort arguments next, but first we will check in. Okay. How much did that get us? Oh, yeah, another, what, 12 lines? It's a good action. If we can get under 38,100 today, that'll be good. Get down to 38,000 or something. And then, of course, I mean, if you're on a roll, you write several hundred lines in a day at least. So Like all these gains in lines of code count will be lost again later as we add more features, but that's good. You want to make room for more features. Okay, let's look at sort arguments. First of all, who calls it? Overload checking, polymorph checking, and probably struct checking, and there may be more. So who calls sort arguments? Bytecode runner for, what are we doing here? Dynamic respecialize. Okay, that's no surprise. Oh, and it's just so that we do struct polymorph. I see. Because structs have named arguments. And you can specify them by name. Part of what sort arguments does is if you use argument names, then it reorders the things that you passed based on what the names say. Sort arguments in struct polymorph. Wait, what? That looks redundant. Because it's using the inst. Maybe there's multiple overloads. Yeah, there's multiple overloads of struct polymorph is what's happening. Yeah. So that code that I was just looking at over there called this one. I mean, dude, all this stuff could hopefully be removed anyway. I mean, okay, this stuff is all fine, but all the stuff up before is like essentially duplication of logic of what happens on the lambda, but it's a little different because it's a struct, so hopefully we can combine that. Yeah, this is all features at the bottom, but at the top it's like just marshalling the arguments, and so I think okay, that's one potential thing to do. Instead of, we're going to look for a little bit at simplifying sort arguments, but simplifying struct polymorph would also be a place to win right now. Sort arguments called from sort call arguments may be polymorph, no surprise. Sort arguments called from the overload resolution, that's no surprise. Sort arguments called from, return. So when we return things, you can return values by name. And again, we're using sort arguments in that way. This is a lot of things though. But the first 4 are kind of needed, and that's the site. Let's look at what all these last bunch are. So you have an unsorted list of expressions and some names that may reorder that or not, and then you have sorted. I mean, we could maybe break it into a multi-phase thing. I don't know. Okay, procedure call flags. The struct that we're sorting arguments on, if it's a struct. Updated procedure call flag. I mean, this could be an in-out parameter probably. Silent check. All right. Let's just start looking at that. whale. If there's a procedure expression, well, all this is just to figure out if we're varargs. Okay, so what happens is either this is null or this is null, which frankly let's see if we use those for anything else, because we could simplify that otherwise. Procedure expression. Okay, that can be something else. Yeah, so we don't really use procedure expression except there. So the first thing I can do, instead of using procedure expression, I can say test this. I can say if we're in this mode and the call flags, right? So that should not change anything. Okay. So we're going to call this argument holder instead of procedure expression. Well, let's look for desk. Does anyone use desk except this? No. Okay, good. So we're going to turn these into one argument. We're going to say we're passing in whoever holds the argument, and it's going to be either a procedure or a struct. And if argument holder type is asked struct, holder defin equals desk defined type, else holder defin equals argument holder inferred type. Right, so if it's a struct, its inferred type is going to be type, right? So, but you want the type of struct that defines. Autodesk static cast struct argument holder. Okay, so if it's tagged struct, we cast up to struct and do this. Otherwise, we take the inferred type, and then instead of all this stuff down here, we say this. Bool is varargs equals and instead of def, this is holder defin. And since we don't use holder defin, well, let's leave it like this for now. See if that works. Well, it doesn't compile. Oh, because I didn't change. It's C++. Oh. Okay, well, not only that, but I didn't change the calling site. So we got to do this. We got to find everyone who calls sort arguments again. So let's go to bytecode runner. So this is for the struct, and is it base? Yeah, base is the struct description. So we're going to pass that here and remove this. Who else calls sort arguments? Typer. Of course, Typer calls it. So here, proc expression, whatever, and then this null was the struct argument, so we're getting rid of that. This sort arguments. This is the proc expression. Yeah, it's this. Oh, right. They can both, wait, I forgot about the return case, which is important. Important sort arguments. So the argument holder can be null if it's a return, in which case it's just like, well, if argument holder. Okay, that's good though, because this, yeah, fine. We're going to do it this way then. And we might want to get rid of this holder definitely, but whatever. Okay, and then I forgot to delete all this code. That's not useful anymore. Okay. So, is that everyone who calls it? I don't know. Who's complaining? One more, polymorph. 1384. Source desk. Right, this is the... whoa! What was that? I don't know what that looked like to you guys. I like hit some keys and Windows did something really weird. Hey, look, that worked. Hey, that's working. Okay. Minor victory, but again, these minor victories add up. How are we doing for code? 131. So we gained about 2 lines of code. Gained in the negative direction. Overall. I would have liked more than that out of that, but you know, you get what you can get. Okay. You know, we could get another line of code here, easily at least. Yeah. So actually, this whole isVarargs thing, we set it up, and then we only use it right here anyway. So to initialize this, which is what we really want, so I think we fold both of these into one thing. I think we say if argument holder we do this stuff, and we say if this, then we do this stuff. Oh, geez. Nope, that doesn't work. Well, no, not worth it. Whoops. Not worth it to monkey with that. Oh, I screwed something up. It's not worth figuring it out. Just revert because we haven't done anything. All right. Okay. Let's look at this procedure call flags argument. Well, let me just, I want to look at this var's target type a little bit. So that's only used to check spread. So like, I don't know. I see, we're also computing this length down here. Well, yeah, okay, so let's go on and look at these procedure call flags. So that's all we're doing is checking for spread there. Spread is when you pass an array into a varargs procedure with the dot dot. We demoed that a bunch. And then updated procedure call flags. If we get let's look at who uses this. I vaguely remember doing that, but I don't remember the specific case in which we do the update. I don't know if we're updating the same flags as here. All right, well, it's the next to last argument. So that's null there. Updated flags, we use it there. Let me skip that for a second. Updated flags. Null. Null. So it's often null, but in these two cases it's not. So updated flags. is for what? Nothing, right? And wait, that must come in from the caller. Okay, that's why we want it. It's because the caller wants it. And here, what is this? Resolve potential overloads. Here the caller doesn't want it, so how do we use it? Updated flags. Where's the definition? I don't see it. I don't like the syntax highlighting here because it's hard to see things. There it is. That's right before the sort argument. So it's basically, in this case, it's 0. The only thing this is used for is to tell us if the last argument is spread. And if so, then we set that flag on the call. Now, why do we set that flag at all? That flag is kind of historical. It's one of the earlier things that I did. Like, why don't we just look at the last argument and see if the spread flag is on it? Is it because well, I think it's because maybe that flag can go away in some cases, but then other things are wrong if that's true. Then other things are wrong. Anyway, so the reason we want to, okay, so when we're type checking, we want to know if the last argument is spread because then yeah. This is a little bit weird. It's more complicated than it needs to be because the only time you can ever spread anything is if it's the last argument right now. The last argument, not in the lexically the way you list it, but if it's the last argument in the procedure, declaration. Now again, that I guess might change eventually. So the question is, can I clean this up in a way that doesn't break if that changes? I mean, if it changes, we need something more complex anyway, because a last argument is spread flag is not going to help because you might spread multiple things. So you can have, well, no, I guess, okay, so there's never going to be like, well, I guess maybe there could be two varargs arguments. Maybe, why not? Why not? Go all the way. So if there's two varargs arguments and you spread into both of them, then what information needs to happen for type checking? It needs to know it just needs to have like a spread list. There needs to be a data structure describing the spreads. And maybe we would fill that out and return a pointer to it, which is approximately the same level of complexity as having this updated flags argument. So therefore, I'm not going to try to remove updated flags because I'll just be adding that other thing later, even though I probably could remove updated flags now. That is what I think about that. How would you pass two varargs arguments? I'll tell you. By name, it works fine. So let's say I have hi is some procedure, and it's A is a varargs of string, and B is a varargs of float, and it does something, right? And then when I want to call it, I would say hi of, well, A equals dot dot array A, B equals dot dot array B, right? For example, like that would work fine. And if you weren't spreading both, you could say 3.0, 5.0, 7.0. Actually, it would probably be this, right? You probably want to explicitly do that because otherwise this could also work. Well, no. I don't think I would let you spread and then do this. Like that. That would require extra runtime support for a weird thing. So I don't think we would do that. But, you know, it would work like this. So if you weren't spreading, you could do hi at all. You could do hi equals hello sailor, how are you? B equals 149, right? So all of these make sense. And so if we're going to do super varargs, why not do that? And if you're asking, why would I think about doing super varargs in the first place? It's because if you have some function that, you know, like print is varargs, right? It's like print, you have some format that's a string, and then args is an array of any, right? Well, sometimes you want to add maybe some extra options to this. But you don't want to force people to put the options here, right? I could say options, or option, I don't know, print in all caps is a bool, right? I don't want to have to specify that every time I call print, but if varargs can only go at the end, then I can't have to, right? So really, I would like to do this and say, okay, well, if you don't supply it, it's false. And then when you call print, you can say print, my name is this, my name true, right? Print in all caps equals true, right? So you can start filling in the varargs. Well, let's put two things. My name is, and I am feet tall, 2, right? So we've got varargs here. We've got the format string. This corresponds to that. And these are the args, and then we switch to this. I don't support this right now, but there's no reason why I can't. And if I'm going to support that, I might as well support stuff like this, right? Make sense? Makes sense. I do allocate the array under the hood before the call. That's exactly how it works right now. Yeah, I see. So you were asking you're asking about the stack frame in the first place. Yeah. So it would just be then, and anytime, if you did this two varargs case here, right, we would just do two separate array allocations. Well, because we know we're doing two, you could optimize it into one and just splat the memory altogether. But, logically it's two array allocations on the stack. It's such a rare case, I don't know if you would really optimize for it, but maybe. I mean, the backend might optimize automatically for it anyway without knowing what it's doing, right? Okay. So that'll probably be a thing that we do eventually. Am I only deleting? Yeah, I'm only deleting new stuff. So with that in mind, that's probably a thing that we're going to do, then maybe sort arguments doesn't really need more. I mean, I can cosmetically reduce the number of arguments. So like these two things, the unsorted expression and the unsorted names, always go together. Those are two parallel arrays, so I could just make a struct that has those, but like, why do that? I could do it. Because that would also make some other things look simpler, like in the structs where there are holding arrays of these things, then it would be a different thing. Okay, I'm starting to like this a little bit. Because actually it would be all three of these things. It would be like, oh, here's the unsorted and here's the unsorted names, then here's the sorted things, and here's any updates that we need to make, which right now that's procedure call flags. And later that would be a more complicated vararg spec. The question is if this is going to be one of those things where it just gets messy to use that. But so if I go to the syntax tree, so here's a place, for example, okay, look, we have unsorted and sorted, right, on the procedure call. And then we could also have the additional flags on there. And then we don't need to modify this at all, which would be good in some ways. Where's another place that we do that? So the return statement, again, has these three things. Type instantiation, although type instantiations don't have the sorted thing, so that would be a waste if we were to use that type here. So maybe we wouldn't use it here. And those are the three cases. So it would just simplify two of these cases. Maybe we make a thing called argument list. I don't know. I'm going to just keep that in mind, but maybe not do it yet because it seems a little too cosmetic. I still, there isn't like a win from introducing that abstraction that I see right now, except for reducing the number of arguments to this routine, which admittedly might just make it easier to think about. But, you know, like a standard programming book or teacher or college course would tell you to do this right away. But I'm not, you know, a lot of times these end up just being, oh, I did a bunch of typing and my program isn't really different from how it was. Except that now there's more abstractions to understand, which is sometimes not good. Let's look at argument sort mode. Whoops, I didn't mean to do that. Mode. Okay, so we're using that for error reporting. Are we still in the same routine? Yeah. Error reporting. It's all just for error reporting. Yeah, it's all error reporting. Which we want. Yeah, I sort of feel like this is just how complex this is right now. Argument holder and cite can probably often be the same thing, but well, let's see if we pass cite and argument holder as the same thing all the time. No. Right, obviously not, no. So this cite is where the error report refers to, and this is like the structure declaration itself. So if we made those the same thing, error messages would be ununderstandable a lot of the time. So I just kind of feel like this is approximately how complex sort arguments wants to be. We made it one thing simpler. But it is not the right place to keep pushing right now. Well, let me read this. This comment at the head. You know, like I said the other day, yesterday, I guess, I often just don't actually look at the lines of code that are there. My brain just skims. So I've been skipping over this. You can get rid of the argument call. The argument call doesn't exist anymore. This is really old. Probably what happened is we used to pass, I remember this now, we used to pass in the actual procedure call. Well, we did especially, okay, so we just replaced it by argument holder, the call expression that was here, but it wasn't casted to procedure call anymore, I don't think. And the reason it used to be was because we used to modify the procedure call flags directly, but that turned out to be a bad idea because you want to be able to roll back changes if they were just exploratory and stuff. So this whole comment is no longer a thing because this updated procedure call flags is about doing that. I mean, the only other things that I can think of is maybe moving cite to the end here because cite is usually an optional thing that goes at the end, or not optional, but it's cite and silent check kind of often live together at the end, but that's minor. Let's not do it. Let's just make sure we're still in working order, and then I'll check in the comment removal and take a 5-minute break to make some tea because I could use some caffeine right now. All right. So that all works. So I'm going to make some caffeine. So maybe I'll do a few more questions off topic potentially when I get back from caffeine break, so you can think about what those might be. see what the questions are. Have you mentioned other programmers before? Do you have advice on how to get greener programmers thinking about the code they write as opposed to just copying existing code either from elsewhere in the project or on the internet? I don't know, man. I mean, people have to want to be good, right? That's the number one thing. If you want to be good, then you seek out ways of being good. And if you don't, then you don't. And there's kind of a weird culture now in younger people that everybody is equally good or supposed to be equally good. And that's just wrong. It's obviously not true in any discipline. And so, and that it's, there's sort of this weird thing where it's politically incorrect to believe that people are not equally good at things. And that's just wrong. And if you believe that, it's like anti-progress in engineering, right? I've said this to a couple people over Twitter, like the whole idea of engineering, the discipline of engineering is the belief that some ways of designing and building things are better than other ways, right? Some ways of designing a bridge result in a bridge that lasts longer or holds more weight or withstands larger disasters and so on, right? This is obvious. We have hundreds of years at least, actually, go back to like Rome or something. We have a lot of success in the idea of engineering. Not everybody gets to be on the Olympic soccer team, because if you put random people on the Olympic soccer team, we would lose the Olympics, right? So this is a very tangent rant at this point, but it's just like technical disciplines are about being good at what you do, because what you're doing is building a thing that meets functional requirements, and the better you are at what you do, the higher the level of requirements you can meet. So I would hope that all people really want to be better, but like a lot of the time people just don't summon the motivation necessary. So I don't know, that's like a whole thing, man. Did I have to pay a lot of money in order to get the quotes inside the witness? Yes. I forget exactly how much, and it was more for some than others. Or no, not really. It was the same amount usually, but from some people we licensed more quotes actually. I believe if you count only the literature quotes and not the videos, is probably about $30,000 or $40,000. I don't remember. It might be a little more than that. It was not $100,000, but it was not zero. It was larger than the budget of many indie games just to license those quotes. What is the parser lexer written in? Handwritten? It is handwritten. I don't think parser generators solve particularly useful problems. Yeah, about this whole question that's going on in chat about whether it's important to look for a solution or not. I mean, I think a lot of the times it's like, okay, if you write something yourself, you will always come out the other end understanding it better than if you didn't write it yourself. It's just, you have a finite amount of time and energy in your life to spend on these things. And so, yeah, you have to be discerning about where you choose to spend your time. And So the way that I like to think of it is at least think about it enough to know that you could implement something yourself. Or if you can't, then recognize that as an area of specialty that you could go into later in the future if you wanted to. For example, say I was writing a physics engine and there was like heat going on and that was important in the game, and I could either write my own finite element heat propagation simulator or find a package on the internet that does that. Well, the problem is there may be, in order to competently write one of those, I may have to learn a whole bunch of things that I don't currently know, because I've never done a finite element simulation of any kind, and I don't know what the state of the art in the discipline is, and so on and so on. So there's that. On the other hand, I was making this example as an example where you obviously should use an external package, but it's not really true, because on the flip side, marshaling data in and out of an external library for something like that, where there's like 3D volumes being described or something, is often cumbersome enough and annoying enough and has heavy enough performance implications that it's actually better to write your own anyway. Like sometimes, like if it's actually tractable to learn what's necessary in the time frame that you have available, then you actually come out ahead if you wrote it yourself, both in knowledge and in schedule, because you didn't take upon yourself the nasty engineering problem of gluing together to this external thing in an efficient way. And then there's all the usual things about using someone else's packages. You don't know if it falls on its face in certain conditions that you're going to have to deal with. You don't know really what its performance is like, et cetera, et cetera. A more simple example, though, is like fast Fourier transform. Don't write your own fast Fourier transform unless it's just for your own educational purposes, right? Because there's good ones out there, and they're well tested, and they're fast, and they're good all around. And so, like, that's a case where the only time you would do it is if you're genuinely an extreme domain specialist and think you have a crack at doing it better in some way, or you just want to learn, right? So just pick your flavor. I got to get rid of this tea bag before it oversteeps. I have a small amount of lunch here. So back to the recordings question. The thing is that copyright in the US and Europe is really draconian. It's like 70 years from the death of the person who wrote or said the thing. And I believe, that was extended. There's this whole like Mickey Mouse law thing where Disney keeps pushing for longer and longer copyright. And so basically anything after about if somebody died, The Witness came out last year, right? So if somebody died after 1946, then we pretty much for sure couldn't use it. And then often there are cases where if somebody died before 1946, we also couldn't, reasons vary, or laws vary in certain parts of Europe and stuff. I don't remember the exact parameters. I consulted with a media rights licensing specialist who knew the rules and helped get all the, or got all the approvals from all the people. Finite element simulators, yeah. I mean, that whole realm of numerical programming is pretty cool. And I also feel like probably like a lot of awesome software, numerical software could be written that doesn't currently exist just because if I remember back in college, all the people who were in like physics or chemistry or something were not that good of programmers because their focus is on their discipline of study, right? And so I mean, obviously you can hire good programmers to build something or whatever, but I feel like there's just friction to having the best work happen on stuff like that. You know, aside from obvious exceptions, like the well-known linear algebra libraries or the well-known, you know, signal processing libraries and stuff, but like, I don't know, like the random, you know, if you read some article and they talk about like how they are simulating the galaxy with a point gravity simulator running on billions of stars or whatever, you're like, is that, if I actually saw the code for that, would I think it was fast? Or, you know, would I be able to make it way faster? And the answer is it probably depends, right? I mean, that kind of thing, it's probably already using well understood algorithms to make things fast, so like multi-grid methods or whatever. But like the pedal to the metal part of programming, that the non-algorithmic part of making your program fast, I feel like I've ranted about before, I feel like very few programmers percentage-wise in the world really understand how to do that anymore. So I feel like all that kind of stuff probably could get 10 times faster, right? Trivially. Although now, like, it's a little different now too, because now stuff like that is probably farmed out to GPUs all the time. And that's its own whole discipline, right? So I don't know. I'm just saying stuff at this point. I'm not going to do super off-topic questions like retreat questions. I'm sticking to technical stuff right now. Just because I don't want people to come on YouTube later to run into like totally off-topic questions. What do I think is the biggest thing that game programmers can learn from programmers of other areas and vice versa? I don't really know. I mean, I do think game programming is one of the hardest kinds of programming, but I mean, if you program web pages, it doesn't. A lot of the knowledge of a game developer is not applicable to your domain because your problem is so far removed from that. So I'm not sure. I mean, I do think like a wisdom has been lost in all this flurry of what would you call it? You know, non-strongly typed languages that happened sort of in the past 25 years. I think basically technology regressed by a couple decades and we've been getting it back that like, no, really, you want a strongly typed programming language, right? Whether it has explicit declarations like C or, you know, type inference or whatever, you like need that, right? And that's the primary handicap that all these, you know, like web people are suffering from. And they're starting to do things like program in more strongly typed languages that post-process their output into JavaScript or whatever the hell. It's still a disaster, but it's less of a disaster. So I don't know. But as for what game developers can learn from the outside, it's hard for me to say because I see game development a lot more closely because that's where I live. And it's hard to generalize, right? You have programmers of all skill levels. They're working on all kinds of different things. And I don't know if there's a thing that broadly people can learn. I mean, everybody can learn something, but I don't know if it's the same thing for everybody. Is this what guys like Martin Thompson are calling mechanical sympathy? Maybe. I don't know what that is. How do I get away from web dev? I just quit my job because it was somehow boring and stressful at the same time. Do you have side projects that are non-web development? If you do, then you can show those and say, hey, I did this stuff. And then it's easier for people to see why they should hire you. So game programming is unstructured often, but there's a reason for it, and it's because we don't know exactly what we're building, and so trying to be over-structured and over-planned about that ends up screwing things up. Like game development in the 1990s and before was a lot more of a waterfall model, and that fell apart in the 90s, before games even got too complicated, right? So even the way I'm writing this compiler is unstructured, right? I'm not writing design documents for the compiler. I'm not writing milestone plans for the compiler, right? And it's because I don't know what the end product is exactly. I have a much better idea now than when I started, right? But that doesn't mean the code ends up bad, right? And the reason it doesn't end up bad is because I do stuff like what I'm doing today, where I keep hammering on it and making it better and redoing things. When you end up with code that's a mess, like you're alluding to in the comments, like someone just gets a game out the door, that's because they didn't care enough to make it good, or they didn't have the ability to spend more time to make it good, and whatever. That's all. Sometimes it's for budget reasons that you don't have the time to make it good. That such is the world, right? Casey talks a lot about how he doesn't know how to do iterative game design in his handmade hero scheme. He also says he would be way more suited to talk about and show how to do it. I considered showing some real iterative game design live on stream. Maybe, it's just that I would have to do that on a toy project aside from the many projects I'm already working on, some of which have not been announced, so you guys don't know what they are. Like, I'm just doing too many things right now to add another, toy game where I talk about how to design it. Maybe someday in the future we could do that. I would enjoy doing such a thing. It's just I have too much happening. How many projects am I working on currently? That's kind of classified. I'll say it's at least, so we're working on the iOS version of The Witness to get that out. I'm working on this compiler, and I'm working on the Sokoban game. So the answer is minimum 3. I don't do very much these days, except program and then go out dancing once in a while to blow off steam. Because I have so much to do before I get old and am unable to think anymore. Or get horrible carpal tunnel or something. Would I ever become a teacher? Maybe. I mean, I would enjoy that, but it would be more like a kung fu school kind of a model where you're actively practicing all the time. And that's the kind of teaching. So it wouldn't just be me talking every day. It would be like, oh, here's the project I'm working on, and I'm working on it in an open way, showing the students why I'm doing things and stuff. That'd be cool. We are doing the iOS stuff in-house with with a contractor who is not an employee and who lives far away, who is doing a significant amount of the programming as well, because we needed more programming time on it than we had. So, but it's not like we're not going to some iOS port shop, because frankly, most of the time that would be a disaster, because the games those guys work on are like simple 2D games usually, or they're like a Unity thing or something. Like a full-blown, fully featured modern game engine is just not something that most programmers know how to deal with, unless they've dealt with it before, right? And most of those shops have not. So it just seemed like a bad idea to even try. And then plus, The Witness is an especially fragile game because it's very easy to break the gameplay by things looking wrong or whatever. So there's all that. We felt we would be able to quality control it better if we did it in-house too. Sean is older than me, but not tremendously older. I mean, I think I don't know, I think he might be 4 years older than me or something. I don't know anything about Godot Engine, never heard of it. What's the most important thing I should focus on when learning C++? Just, for me, what works is to just think about what I'm trying to accomplish and then just learn the parts of the language that let me do that, and then keep learning the language and see if there's a better way than what I did. But for me, always like grappling with the problem helps put the ideas in context and helps me understand how I would use them. Okay. Whew. I almost want to break after that questioning session again. So what am I doing here? I looked at sort arguments. I knocked out one of the parameters. I thought, well, maybe it could be simplified further, but I don't think so now. Now, in the higher level task, again, what I'm trying to do is be able to put the bakes in here. So we sort the arguments. Okay, so there's this make polymorph of called procedure. Which is going to need to do type checking and stuff to so I think that's what we look at next. Of called procedure. Right. Right, this is all the match solver input stuff that we glazed over before. So we do all that. Okay, but by this time, we've already picked the source lambda. Okay, so this is too... No, it's not too late. Never mind. Overloads keep confusing me. So that's a whole separate issue, but we've resolved the overloads. We do this match solver stuff. We solve for matches. And solutions is a match status. Okay, so then we call do polymorph with solutions.matches, and we check for yield on solutions.matches. So if we do the bakes here, just by adding them to solutions, that should be enough. So we're about to do a scary, scary change. So let me find, so resolve potential value bakes. You know, it's doing all this stuff. It's like, okay, if a particular declaration okay, let's just go for it and try to insert the big stuff here. Let me make sure only one person calls that. Yeah. So, we insert the big stuff here. So, for in I equals 0, I is less than args dot items I plus plus auto expert equals args of I. Well, yeah. Whoops, I'm in the wrong place. God, all this code is going to, or a lot of it's going to go away. It's going to be great. Okay, so if, so I'm going to start pasting over here. All this deciding whether to accept something. And if we accept, well, for now we're not going to do anything. So I'm just going to see if this compiles. This is going to be so much better unless something comes up to stonewall this attempt. Eval expression to literal, right? Interp typer. Is there no interp typer? Oh God, I have to get available typer. Well, okay. If call resolve procedure expression inferred type def and flags. So the reason I'm putting this extra if around is I'm going to do something slightly expensive. So I want to get the type checking module, which used to be sort of global to interp, but once I started threading the compiler, then you have to query one. Let me look for someone who does this. Yeah. So you have to say get available typer and release, right? So I'm just going to do that. And just the fact that I'm querying this thing, it's like, well, yeah. Of course, we don't actually multi-thread the typer right now, but we're hoping to be able to. Okay. Let's just see what happens. Oh, and then this. Okay, that compiled. Now this code that we added doesn't do anything ostensibly except crash. Let's figure out why that happens. Call resolve procedure expression was null. Oh, right. Oof, oof. Okay. Because we haven't, we're figuring out the resolved procedure expression. So it's not set yet. By definition, it's not set yet. So you know, if this has auto value bake, the source lambda will have auto value bake, I believe. Source lambda, right? Because you can't, like we're looking at polymorphing something. So like that, yeah, okay. So that runs. Great. And that runs. So now let's make sure we actually get here. We want to actually be accepting something. So let me just assert false. So if this is actually working and we're hitting an accept, then our program will crash. Yes, okay, that's good. That is good. So let's then go back to here. So once we decide if we accept, we're making a polymorph match, right? Yes. And this, and then we're just going to say solutions.matches.add item. Oh, God. That's so good. That's so good. All right. And then this stuff. Okay, if we didn't accept, then we do error reporting, is what's going on. Okay, now why? This is the one thing that troubles me. Why? What is this? It's all for this other. Oh boy. Oh my God. Okay, this is the fly in the ointment. So when you bake a value, you're not passing that value as an argument to the procedure anymore. So what we're doing here is we're modifying the live arguments that we pass. I mean, we're resetting it and then just adding these guys. I guess I could do that here. The problem is, I mean, what if it's a silent check? I guess, oh wait, I'm even looking at the wrong one. I'm looking at the overloads. Oh no. Okay, sorry. So resolve potential value bakes doesn't, okay, right, okay, so if it's a silent check, all right. Okay, so if it's a silent check, we don't bake. Because, you know, there's no reason to bake these. All right. So post value bake, we need to find that and have that. And okay, so if the declaration is not attempting to bake, we add that, and then hopefully do polymorph well. Okay. Does that compile? Oh, post value bake has to survive the scope. Post value bake. Did bake equals true. Bool did bake equals false. Post value bake. If did bake. If you did bake. Do that. Okay, does that compile? Yes. This is, okay, this is scary. Like, I'm not even gonna guess odds of this working. I honestly have no idea. They're low. But the odds that it's not easily fixable, I don't know. Oh my God. Did I really compile? Yeah. Oh my God. Getting things right the first time. When you do something scarily complicated like that and it actually works, dude, it's amazing. It's amazing. Okay, so what this means is we get rid of this. We get rid of all of resolve potential value bakes. And we've gotten rid of our two-phase polymorph. Now let's actually see if we won on lines of code. Well, let's test to make sure it still works. No, not that one. That's the release compiler from days ago. This one. That still works. I can still push the block. Yeah. Procedure call polymorph and bake is now single phase. There we go. That is awesome. That is so much better. Okay, so now, how are we doing code? We got like 18 lines of code out of that. It's funny because the line of code count, the structural win there was huge. And the line of code count is like, okay, a little bit. But the structural win is huge. Huge. Because procedure calling, the thing is, procedure calling is kind of the real workhorse of the language, and it's got all these complications that come together, right? So it's got varargs and casting to any and polymorphism and bakes and inlining, like all this stuff, right? So, you know, like a language like C++ was like, oh, we think, and named arguments, right? And overloads, there's just a lot of things that come together. So like C++ is like, hey, we'll let argument passing to procedures still kind of suck like it does in C, but then we'll add objects, and that's what make our language good. And the philosophy here is like, no, what makes a language good, well, in part is because we're very thorough about the features we have. So we're very thorough about procedure calling, but that means it gets complicated. And so if we can simplify it to minimize our problems later, we should. And that was a massive simplification. So that right there that I just did is the main thing that I was hoping to do out of these couple days. So that is victory. However, it's not everything that is on my list now. So, you know, I'm going to want to look at how overloads happen and see if I can simplify that a little bit given all the other things that go. Because, you know, sometimes once you've simplified some stuff, you now see how other things can simplify. And then looking at struct polymorph and seeing if that can share code with other stuff. I'm pretty confident if I don't get tired, we'll be under 38,100. I should be able to get this other 15 lines. All right. I've missed a lot of chat, so I'm going back and looking through the chat a little bit. Okay. People are talking about coffee. People are talking about coffee. I might have to do another gaming stream tonight. I might go back and play a little bit more of Zelda just because, I mean, I don't like it, but I want to see why people like it. So I want to try and get to more of the temples and see if any of them are non-trivial. I don't know. What register am I using for the context pointer? So currently that's just implementation defined, right? It's going to change per architecture. And it's not even necessarily smart to dedicate a register to it, because if a procedure doesn't use the context, which it may not, especially if it's trying to be fast, it's not going to like allocate or log or anything, right? So, and if it's trying to be fast, it needs the most registers. So I think the proper thing is just that the context just gets managed. Its use of a register just gets managed like any value in the language, right? So if your optimization, if your peephole optimization says, look, it makes sense for this to be a register because this will go faster than it is, otherwise it isn't. So it's not like we're, you know, holding R15 to hold the context or something. That said, there is a question of what the calling convention is, and does the context go in a register in the calling convention? And I'm not sure what the right answer is for that. Maybe. But then it might get spilled right away in some cases and just go into memory, and that register gets reused. So who knows? Yeah, maybe I won't play Zelda. Maybe I'll play a different game. I can't take more of that game. I'm feeling a little tired, but streaming always makes me tired. But this has been good progress, so I want to just look a little more. I want to have some chocolate, and then look a little more at some of these things. Maybe the right thing on structs is to leave that for tomorrow, because I feel like that's going to be. On the one hand, it's going to be a big thing, but on the other hand, all the groundwork has been laid now, so maybe it should be easy. And I just did a massive thing, and it worked the first time, which is astonishing. That's also the sign that things are getting simple enough to be tractable, right? As when you don't start tripping on all kinds of state landmines when you make changes. Let me look at overloads. Maybe this doesn't really have anything to do. When we call type check one overload, so the funny thing is, all that stuff, so I combined those two phases into one phase. But the funny thing is, in the case of overloads, that one phase is going to happen twice anyway. Because we do a type checking pass to figure out which overload to use. And we report if we get more than one, right? And then we return that overload and say, hey guys, use it. Really, I suspect that maybe when we do type check one overload, we get a fully instantiated procedure back, except it wouldn't have the bakes because we didn't do silent check. And we don't want to bake things that are not the right overload. That would just be a mess. Although maybe it would be fine. Why is this not a local array? This should be a local array. Okay. See, this is so weird. Like, I feel like we do so much redundant work. I mean, never mind that this compiler is way faster than most languages. We still, I feel like, do a lot of redundant work. So, like, we got these overloads. And then we count the casts down here by resorting and type checking all the damn arguments, which we already did, right? So maybe the thing to do, maybe if I don't worry about the polymorphism part yet, right? So if you've got multiple overloads that at first glance are both possibilities, you know, we see how far away they are in terms of number of casts and stuff. So why didn't this happen when we resolved the overloads? Then we wouldn't have to do all this, right? And again, we might save some lines of code out of that, but also just structurally, like we wouldn't have yet another call to sort arguments and type check, like this just, like why are we doing that, right? So like when I have type check one overload, I could have that return the cast count and then put that into a parallel array. So if it matches, right, then I could put the cast count information into an array that's parallel with the overloads, I guess, right? Wait, no. Oh, this is the error reporting, sorry. This is the type check one overload that actually tells us what we're doing, right? And it adds to matches. So we could say if success, add to matches and add, and that said, why does an overload info just have the cast count in it anyway, right? So then, you know, then we have to transplant the useful part of this, but we get rid of all this, which is great. And it would be less redundant type checking, which will speed things up. So type checking, by the way, if you guys remember the time when I was using the visual profiler on the compiler, if anyone saw that stream, you know, type checking was the part of the compiler that uses the most time. And so things like this, even if they don't take away the lion's share of the time, they'll reduce the complexity of what is being checked when, and that will make it easier to optimize what's left. Okay, I'm feeling good about this. Feeling good about this. So let's just look at overload info. Who uses that, and what does it look like? So here's the declaration. It's the declaration that we started with, I guess, the final, the scope distance, like how many scopes up it is from where we are. And then I guess we'll put the cast count in here. So who uses these? There's an info there. This is the code we were just looking at. Yeah. So much cruft will go away. Yeah. Yep. So let me just go here to overload info, and I don't even know if cast count is in scope here, so let's go cast count, cast count. Apparently it was. Okay. Type check one overload. So collect overloads gives us anyone. So before looking at the argument, we get all these guys. So these are going to have cast counts that are just 0. They're empty. It's fine. Then once we get here, type check one overload needs to take the entire thing, the overload equals n overloads of I. Overload final decal info type. Pass overload here. So we type check one overload, auto overload, overload info, final decal, info, overload info. Let me make sure nobody else calls this, because that would be bad to try and change it and someone doesn't have that information. Who is this? Okay, this is just that, right? So this is fine. Type check one overload, overload info, overload info. So one overload, this is fine. And then when we print out the possible overloads, we do this again. Overload. See what happens. 2905. If success matches dot add star overload. Okay. Let's see if that works. Appears to. It's, by the way, you know, this is one of my main methodologies of programming, is to like keep a working program and then maneuver on like the isosurface or the contour of what keeps that program working. It's a tremendously effective way to work. Because you know as soon as you've stepped off that surface. So I recommend it. I mean, this is why, like, you know, when there are test-driven development zealots, this is kind of one of the reasons why they're zealots about it too, is because it's effective in that way. I don't like test-driven development. That's not what this is. But it's similar in that I'm taking steps and testing every step, right? Okay, so this is good. So did I run Sogoban? Yeah. Type check one overload takes an overload info which has a cast count which we do not yet use. see. Oh, there's some questions about what is going on. Let me see. What is this bake feature? Creates a baked instance of polymorphic function. Is not polymorphic. Not quite. It could still be polymorphic. Haven't been following closely, but here's how I understand it. Lambdas are in general closures, but sometimes can be represented as procedures functions. Bacon's process of working out which ones can and making them into that. Not really. Yeah, so partial evaluate, this is basically the C-style version of what is known in functional language community as partial evaluation, right? This is what partial evaluation looks like. The bake feature, not the other polymorphism stuff that we're doing, but the bake feature specifically is what partial evaluation looks like in a fully imperative C-style world, to sum up. Well, the programming language on the screen is C++, but we're implementing another programming language. Okay. And then there's an internet flame war developing in the comments section, or in the chat, which I will stay out of and instead have a little bit of chocolate. Okay. So on every overload, we have a cast count. Now, type check one overload ought to be able to set the cast count, because look, it does this, right? And then we shouldn't ever yield here, but it doesn't matter, we're going to delete it. So I'm going to take all this, and just paste it. Boom. Boom. Let's see if that compiles. That's the actual useful code mostly. All right, let's make sure that didn't mess anything up. Okay, great. Awesome, we didn't break anything. So now we have a cast count. Instead of current count, we're going to add 2. Well, we'll do it. Auto count equals end overload cast count. I'm going to say count arrow, and we're going to say count and we're going to say count Now that's still not going to do anything because we're not using the cast count on the overload. But I just want to make sure, well, first we got to fix the file errors. Oh, right. Overload info cast count. I'm going to check this in if it works. Because anytime we come up to a particularly scary step, moving toward eliminating redundant type check for cast counting. Yeah. So, now, instead of doing all this stuff, where's best count live? I guess it's outside the scope. So we're going to compare it.castCount to best count. And that ought to do it. Maybe. What did I mess up? Current count undeclared identifier. Inline 3037. Best count equal, right? I was looking right at that. Well, let's find out, folks. Ha ha ha! Of course, I don't know. I mean, maybe I don't have a pathological enough test case, but like, look, man, it's all working. It's all working like it's wearing a jerkin. All right. So, this goes away. You get a car. You get a car. Everybody gets a car. Maybe we can do this in a way that's more efficient than generating copies. Like maybe or maybe we just steal the info, the memory, so it's faster. But that is a micro optimization of the kind that I am not interested in. This could be a local array though. Local array is a thing that has like 4 or 5 slots already allocated on the stack, so it doesn't go to dynamic allocation for small numbers of things. And in cases like that, we're only expecting like one match, right? If your program's correct, it's only going to have one polymorph match. So we don't want to use any like long-term memory in that case. So that's why I switched these things to local array where it makes sense. Okay. That is so much better. Let's see. Is there anything else? This scope distance I'm going to write that down. Scope distance in cast count. Well, that seems pretty good to me. That seems pretty good to me. Count. Oh, okay. Well, net gain of 8 lines. But again, that's an important 8 lines because we removed a call to sort arguments, we removed a call to type check arguments, and we removed redundant computation of casts. Like that's good stuff. In terms of simplifying the core, that's an important 8 lines, man. You know, there is some polygon tearing on Sokoban guys sometimes. It's not tearing. What's happening is there's some kind of like in the mesh loading or in the uploading to OpenGL more likely is where the bug is. Like I just don't quite do it properly somehow. So sometimes polygons are obviously corrupted, a small number of them. I suspect it's like the ones living at the end of the guy or something. Or maybe I'm using a small index size and the guy needs more than 16 bits. I don't think he's that many triangles, but it's within the realm of possibility that he might be, you know, it's something like that. So I'm just ignoring that bug because it's a relatively unimportant bug and it has nothing to do with the compiler actually. At least I believe not. It always could. There always could be a compiler bug, but I don't think that's a compiler bug. So that's a lot better. That's a lot better. Maybe I'll do this other thing. Maybe I'm going to put scope distance in cast count. Do you know why I didn't post the shadow map video to YouTube? I posted all of the shadow map videos, I thought. You might be looking on the wrong playlist, maybe? There was one shadow map video where I made very little progress, where I was like, this is not productive. And then actually I finished the shadow maps when I wasn't streaming. So if that's what you mean, if you want to see the final implementation, like where I got it from being buggy to working, I wasn't streaming at that time, so there's no recording of it. Am I familiar with actor-based threading model? No, but any kind of fancy threading model, so-called, has everyone that I've seen has been unappealing to me because they don't make sense. The only really fancy based threading model that makes sense to me at all is when you go all the way to like software transactional memory and you have a programming language based around STM and like speculatively doing things in rollbacks. And when that's the case, you want a relatively complex, interesting situation around threading. In other cases, I just, you know, I look at what these languages do and I'm just like, that's not helping an expert programmer do good threading. It's just helping noobs. And noobs shouldn't be threading. So, yeah. I'm pretty sure some of the shadow mapping are on YouTube. Maybe I never uploaded them. I don't know. My own work is mostly on these, but right now I'm working on the Witness iOS a little bit, and I'm probably going to stream some work on that tomorrow, maybe. All right, let me do this cast count thing, and that'll probably be time for a break. And maybe we'll do a gaming stream after the break. Where was overload info? Typer.h. So we're going to move scope distance. Where is cast count live? Cast.h. Scope distance. Cast count. Well, I don't know. It's fine. Okay, so let's look at scope distance. Wait, what? All right. Info.cast_count.scope distance equals distance. So now we just look at compare, and the very first thing I guess it's the very last thing. If A dot scope distance is less than B dot scope distance, return -1. I'm quite sure that's the right thing. Not sure about that one. Okay. Okay, so I'm going to leave this enabled right now, just because. Okay, whoops, who failed? Who failed? Typer.cpp, scope distance is not a member of overload info on PO11. Right, okay. Let's not enable that then, right. Duh, of course I can't keep that enabled. Let's see if that works. So good. This is the day of everything working correctly the first time. Which is a pretty good thing when you can get it. So we gained at least one line of code through that. But again, also we simplified the logic here, which is a good thing. I want to think about this a little more and see if I can simplify it. Count. Oh yeah, we got like 4 lines. Wait, what were we on? 107? Yeah. Yeah, we're getting close to dropping under 38100. I mean, I'm sure there's just some dead code somewhere that's not being called at all. Does Visual Studio have a dead code detection? Is that a thing that I can run? Let's do that, because if I could get under 38100, Visual Studio Team System. Oh yeah, let's do this. How do I turn this on? Code analysis. Yeah, okay. Okay, of course we've got all these other warnings. Oh, but this comes... Well, I hope the old warnings don't make it too hard to see. Okay. New data could be 0. This does not adhere. Oh, because yeah, whatever, guys. Warning dereferencing null pointer OP. Yeah, I guess if you go through that case, that should be an assert. Okay, I want dead code. I don't want... This might help catch some bugs. So maybe we should do it for bugs, but right now I just want dead code. Uninitialize memory R? What? That's not... Oh, because we assert. Yeah, I mean, that's... See, this is the problem with these tools. You didn't give me any dead code. Wait, is there... Let me look at the thing and look at what the strings are. Unused local variables. Let's find that. Never used. Never used. Nope. It didn't give me any never useds. Screw you, buddy. The one time I think Visual Studio is going to do something for me. Upstream. Nope. never used. Apparently, nope. Maybe we have no dead code, but I somehow doubt it. Did we not turn on code analysis? Can I like set options? Tools, options, code analysis. I don't want managed. I don't care about managed. Right click on the properties. Code analysis. Microsoft native recommended rules. I don't know what the native recommended rules are. Okay, this page had these numbers. So let's look for CA 1804. Oh, these numbers are totally different. They're not at all the same. What? I mean, maybe it changed from 2009 to now. Like, okay. Annotations, failing to release lines and suit pointer. I don't care about that. Don't care about that. I want dead code. I've been spending so much time doing this that if I just kept working on the code the straightforward way, I would have removed some code by now. Did they take out dead code analysis? Did it like not work well enough or something? Does anyone see dead code analysis here? I might be missing it. Dereferencing an argument could be one value and his function is described as A is calling memory. Memory due to an exception is illegal and consistently annotated. Use this. What? This is a hard compile error. Why is there a warning for these? What are you guys even talking about? Maybe if you overload that operator, it's ridiculous. I don't care about annotation. I'm just looking for dead code. There's a search bar. Yeah, but I don't know what to search for. I don't know what word. They're not going to say dead code, so I just see a bunch of, I want to search for not annotation because I don't care about anything that says annotation. Like, how is anyone supposed to, yeah. Oh my God, this is all annotation stuff. Each wind broadcast, are you kidding me? Banned API usage. Deriving the leaking man, your termination, bad concatenation. Dead code in bitwise or limited switch. There is this phrase dead code in here. Whatever. Okay, let's search for dead. Okay, let's search for unused. Let's try that. My rule set. Okay, did that change it in the properties page? Probably not. Run this rule set. Browse. My rule set. See what happens. Unreachable. Well, I'll try that one. Yeah, I don't want to enable the code analysis on every build because it's slow. So I don't want to leave this on. I want to do it once and find some things from that. Oh, I just had it again? Looked over what? What are you talking about? What did I look over? Well, I don't know what to search for here. Dead, unused, unreach. I simply don't believe that there aren't unused parameters. Well, here's an unreferenced label. Let's get rid of that. That's great. Save us one line for all that time. Return value ignored. Yeah, I know. We shouldn't do that. It's fine. That's a good warning. Except it shifted right and then shifted left, so it's, I don't know. Maybe this is questionable. Yeah, it's just I don't know how to find the warning in all these warnings. What's happened in the past 2.5 hours is massive victory in the polymorphism cleanup. And so I'm just now, I was trying to use the Microsoft code thing and to get us under 38,100. And I thought it would be a quick thing, and it's really not. Let me do one more. I'm going to search for unreachable as was suggested. Wait, what? No, I changed it. I changed the rule set to my rule set. Apply. And let's open it anyway. And let's search for unreach. Invalid size string unreach. I don't even know what that means. All right, well that wasn't helpful. So if I go back to the page, no, don't run this rule set. Oh, what? It says this here. Oh, copy of native. Okay. Copy, right. So that's what was happening. Okay, I don't know how to get useful information out of this. It told us about a label we weren't using. That's fine. It hasn't really been 100 lines today, I don't think, but it's been 80 something, I think. But the structural changes that came with that 80-line netwin are huge. They're just massive. Like, I'm almost done with everything that I could have wanted to do with the cleanup. That's how good it has been. Okay, I'm giving up on this. I mean, I'm sure there's just stuff like, hey, there's methods in Typer that don't exist anymore, but they're in the they're declared. Like, I don't know, I'll try a few. Maybe lax course, okay, that exists. I don't know. Check for polymorph casts. I'm pretty sure so this is just a debugging function. This is where we get all our win from, because I'm pretty sure I just do this and this. I think. Let's close this. How do I close this? All right. I hope that didn't do something bad to my executable. Well, let me do a clean build just because I don't really trust that. All right, so that's going to get me so much. So that's not a big win. It's going to be a bigger line of code win than a lot of things that were done today, but it's not like structurally, that was just a little extra tiny benign tumor. So count. 38086. We're up 100 lines now for the day at least. I think we were at 188, or was it 186 or 182? I don't know. We're at about 100 lines. Search for unreachable in your warnings output on build not encoded analysis. I did that as well, actually. After you suggested that, I searched for it and it was not there. Yeah, the display name thing was confusing me. Okay, I think that's a happy enough victory for me to take a break for the day. That might be all the there's still more polymorph cleanup to go. The struct polymorphing has to be attacked. However, maybe I do that tomorrow or maybe later tonight. I think I'm going to take a break and then do a gaming stream. Did both of these things. So many things worked right the first time today that could have gone horrendously wrong. Like easily, those 2 or 3 things that worked right the first time could have been each a full day of debugging if they had gone wrong and been complicated. So it's kind of great that that didn't happen. Well, in the old really complicated polymorphism system, it could have been a full day of debugging or possibly more each. And so the fact that it wasn't is pretty amazing, frankly. Yeah, so if you were gone the last stream, you missed all the big wins, man. Sorry. All right, thanks everybody for coming by, and I'll see you later.